to cut these threads, I'm using a Miyano BNC 34T. Just picked this up at auction. It came in on Monday. We've got it powered up. I've changed the coolant out because it had some gnarly residue. It is a twin turret machine, but you could do this on a single turret machine, no problem. I like the twin turrets because I can have all my stick tools over here for threading, parting off, grooving, and turning in one turret. And then my longer tools, like my drills, are in the second turret. So even though this machine doesn't have a lot of travel, you don't have a lot of crap in your way. It really makes it a lot nicer. So we're in edit mode, and I can show you my program real quick. We can talk about that. So the first couple things we're gonna do, I'm calling up a part stop in my second turret. This is a very non-standard way of programming because these machines are very goofy. Basically, Miyano was very cheap and didn't want to sell you a Model 0 TT for twin turret. They were selling an OT from Fanuc, which is just a single turret machine. So there's a little bit of black magic to make this thing work. But first thing we're gonna do is we're gonna call up the second turret. We're calling up a part stop to feed out to. I'll do that when we read MO. The machine will pause. It'll wait for me to do what I need to do. When I hit start, it's gonna send the second turret back home, and then we'll get started on turning. So my tool is my turning tool. It is a V&MG 332, nothing fancy. And we're gonna call that tool up. We're gonna turn the spindle on at exactly 2000 RPM. G97 is a spindle command saying we're going to tell the lathe what RPM to run at. We're not actually calculating surface footage and all that good stuff. For this application, I really don't care. M93 is a Miyano code. Typically it's an M3 to turn spindle on clockwise. I'm turning on M93 because I always give it coolant and spindle on. We're gonna wrap it up to position at a diameter of 1.1, and we're going to end up 100 thou in front of the part. I know that's a safe number because my bar stock is 1 1/16, so it's 1062, and this is 1.1, so we're solid there. We're gonna feed up with a G1 to Z0, which is the face of the part. Remember, we're still up in diameter. We're moving pretty quickly at 25 thousandths per rev. Then we're gonna face down the part, where we're gonna make sure we have a nice clean face, and we're gonna do that much slower at 2 thousandths per rev. After that, we're gonna wrap it away from the face of the part, get the heck out of the way. And that I need to change. We're going to wrap it to X1.062, which is the diameter of the part, and Z1 100 thou in front of it. G71 is a Fanuc turning cycle, so we're gonna do 20 thou depth of cuts. To make the video pretty, we'll turn that down a little bit, no big deal. R is a retract amount, we'll turn that down a little bit as well. The second line of G71 is telling the machine we're running between line 1 and 2, and it's gonna look for N1 for P1, Q2 is gonna look for N2. We're gonna do a 15 thou depth of cut, or excuse me, we're gonna leave 15 thou for finishing, I'm sorry. W is our Z allowance we're leaving, so we're leaving 15 thou in diameter, and we're leaving 2 thou in length, and a constant feed rate of 10 thou per rev. Our first move gets us into position, and the face of the part. Our second move actually moves us in Z, so we're at the face of the part. 8156 in diameter is the major diameter for a 1/2 inch MPT, and I've got it doing a little chamfer move. And then we're gonna have a taper block, so that's just my standard programming. We're gonna turn back 3/4 of an inch. We're gonna go back 3/4 of an inch, and then we're gonna go up to 875. And when we're at 875, we're gonna go back to a total of 1.5 inches. G70 P1 Q2 means repeat those lines, but do a finish pass. So this is just a profile of the part. It's a nice, simple little thing. And G71 tells the control, hey, you're gonna do some cool stuff. And basically it breaks it down into, instead of me writing, 20, 30 lines, or even more complex than that of a profile, it's gonna break it out and it's gonna do it the way I want it to. That line tells it to do that exactly how I have it, and giving me a finished profile. X 1.1, Z 1 point pulls us up in diameter and away from the part. G28U0 tells the machine to go to home position, which is a safe thing to do to get a turret index for the next thing. And the next thing we're going to do is threading. And this is all that fun stuff there. We're going to run at 2,000 RPMs. We're going to run up to the part. We know we've turned it, so we're safe there. We're still ahead of it. We're going to feed fairly quickly above the part. Then we're going to call up all our threading information, and that's just a 2-line thing. The machine's going to break the threads up and do all of the parameters we want it to do there, and then we're going to get out of threading. And that's it. The next thing we're going to do on this machine is call up a drill. And this machine uses drills on the second turret, which you address as B. We're going to drill about 400 thou deep with a center drill. Page down. Then we're going to come back in with an actual drill, and we're going to peck drill to 1 5/16 deep, taking 100 thou pecks, retracting 100 thou in face of the part, and feeding at a rate of 3 thousandths per inch. Then we're going to get the heck out. B turret will go home. We'll call up tool 5, which on this machine is the part off tool. And here we're going to slow down to 1,000 RPMs with a max speed of 3,000, and that'll be important in a minute. We're going to feed up over the part. We're going to feed back 1.5 inches plus 40 thou, 1.540 at 25 thou per rev. So it's going to get on with it. When we get there, we're going to turn on constant surface footage. So what that does is the lathe is now going to calculate the spindle speed for what we're trying to accomplish. I'm telling it run at 200 surface feet. So it's not going to be at 200 RPM. It's going to calculate the surface footage of the diameter of where you're at. And because we're at 1.1, it's not going to move very quickly. The next thing we're going to do is actually do the actual parting off. We're going to feed past center slowly. It's probably a little too slow for these ISCAR inserts. They're amazing, and they can take a heavy feed and a heavy speed, but for video I have it slowed down a little bit. And as the machine comes down in diameter, as we approach 0, it's going to ramp up the spindle speed, and it gives you much longer insert life and gives you a better finish because you're no longer going too slow nor too fast. You're going right where you need to be. We're going to cross center, and we're going to wrap it up to 1.5 inches. We're going to pull back into the face of the part with a Z 1 inch. We're going to send that home, and we have an MO because that's the end of our program. And that's really all I'm trying to do.